Oops, forgot to close my window. So we're just going to continue talking about for loops. And in this example, I want to try to compute a Fibonacci sequence. And so the philosophy here is I'm just going to keep showing you examples of for loops. I think for loops can be difficult to learn and get the hang of, but once you do, it's a really important and powerful tool. So first of all, let me introduce you to this idea of the Fibonacci sequence. It's pretty famous in math circles, but maybe not so much outside of math circles. It goes like this. The very first term in the sequence is 0. Next term is 1. And then you add the 0 and 1 together, and you get the next term in the sequence, which is 1 also. And you keep doing this. So to get the third term in the sequence, we add the previous two terms. So I add the 1 and the 1, that gives me 2. To get the next term, I add the previous, the 1 and the 2 to give 3. 2 plus 3 gives 5. 3 plus 5 gives 8. 5 plus 8 is 13. 8 and 13, 21. 13 and 21, 34, and so on. So what I want to do is create a for loop that will do this for me. And actually, we're going to do this time as a procedure. So I'm going to have a Fibonacci. I'm going to pass it the term that I want. So if n is 1, then I should get out. I should be able to print a 1. If n is 2, I should print 1. If n is 3, I should print 2. N is 4, 3, and so on. Okay, so def gives a procedure. The name of the procedure, these are the parameters, should always end with a colon. And then we go down the new line, and we always indent to give the code inside of here. Now in this case, the first two terms of the sequence are fixed. So we're going to set f0 equal to 0. And we're going to set f1 equal to 1. And then we need some kind of loop. So we're going to do for I in range. And we'll go up to n. For loop has to end with a colon. And now we need to add the previous two terms together. So I'm going to set, well, let's see, we need a new thing maybe. I don't know, it's not really clear how to do this. Maybe I can make up a new variable, x, and we'll add the previous two things, f1 and f0 together. And then when we're all done, now notice that PyCharm is automatically indented for me to be inside the for loop. I want to go back and end the for loop with just that one statement, and then I want to print off x, I guess. And then from there, that should be the end of it, maybe. So let's see what happens if we run this with 4. Hopefully we'll get 3 out of this. I don't know. Let's see. Run. Fibonacci. Oh, I printed out a 1. Well, that's not exactly what I wanted. Okay, so now we're going to have to do what's known as some debugging. We've got a problem here in our program. We were expecting to get 3, and because that's the fourth term, we got back a 1. So there's a problem with x. X is not the right thing. So a neat thing we can do here is inside the for loop. Well, we don't want to do it before we've used x. After this x, we can print off what x is inside the loop. Now, every time we go through the loop, we're going to get a print statement. That's not really what we want for output. For output from Fibonacci, we want one number. But in this case, we're just throwing in a debugging tool, which we will erase as soon as we figure out what the issue is. If we do that, x is always 1. Huh. So why is that? Well, f0 is defined as 0, f1 is defined as 1, and we don't change those anywhere. So we're saying every single time I want x to be f0 plus f1, we're saying we want x to be 1 plus 0, which is 1. So x is never going to change. It's always going to be the number 1. That's not exactly what we wanted to do. So maybe what we should do is change how we're using x here. And I think, so the problem was that we're defining x to be this constant, which is always f0 and f1. I think what's going to happen is one of these two things is going to have to change and grow larger. Actually, maybe both of them will. This is actually kind of a complicated problem because as we go through, first we have two variables here pointed at these two things. We add them together and we get the next one. But when we do that, we want the first thing to become this, and we want this now to become this, and so they're both pointing at 1. And we're going to add those together to get the 2. But then the thing that was originally pointing here, we want to move up to here, and the thing that was pointing here, we now want to point to the 2, so that those two things can add up to give us 3, and so on. So this is a little bit complicated, I think. We need to update then what f0 and f1 are, I think. So when we're done adding these two things together, so we add the 0 and the 1 together, and that gives us a 1. We want the f0 to become what the f1 was. That moves us up to the next term. And then we want to move f1 up to the next term. And f1, the next term, actually is just x. And since we're doing some diagnostics here, I'm going to print all three of these things off. And one of the important things I want you to get out of this example is the idea that you can always throw a print in to check to see what your variables are doing and to see if they're doing exactly what you want them to do. So I want f0 and f1, even though they're supposed to be fixed at 0 and 1. Maybe I didn't do a very good job of naming those two things. I want them to go down through this sequence. I want f0 to start off as 0, then go to 1, then 2, then 3. And I want f1 to start off as 1, then go to 1, 2, 3, 5, and so on. And I want x to be the sum of those two things. All right, so let's see what happens here. Okay, so we start off. Well, they start off as 0 and 1, but after the first iteration, they chain down to f0 is 1, f1 is 1, and the sum is 1. Then they move down to 1, 2, and the 1 plus 1 is 2, 2, 3, 2 plus 3 is 5, and so our final answer is 5, which is not what we wanted either. We wanted 3. What happened? Well, it looks like we went too far. We should go to get to f4 through, we add 0 and 1 to get 1, we add 1 and 1 to get 2, and then 1 and 2 to get 3. That's 4 iterations. So what's the problem? Why are we going too far? Why are we getting 5 out of this thing? Maybe we should just back this up and not do so many iterations. Let's try this. Let's try only going to n minus 1 and see if that gives us what we want. So if we put in 4, we want to get out 3. And we had 3 right there. Then we went one step too far and got a 5. Let's see if that works. Well, that seems to be better. Okay, so by putting this diagnostic information in, we can kind of get a feel for what's going on here, and it helps us trace our program. So this is called debugging, or in this particular case, we're tracing the program. It looks like we've got the right thing. Let's try a few more test cases. Let's try 7. So if we have 7, we should get 13. Oh, that looks like the right answer. And if we try 9, we should get 34. Okay, so I have some confidence now that this is working correctly. Because it's working correctly and we only want to print out the Fibonacci number, we don't need this diagnostic information anymore. So we can just get rid of it. And that's kind of the neat thing about doing computer programming is you can always just pop stuff in there, and if it works, great. And if it doesn't, well, change it. You're not going to break it. Okay, so now we're just printing out 34, and we could ask, what is the 50th Fibonacci number? Ooh, that's kind of a big one. All right, so this is just another example of a for loop, kind of building on a theme that we had in the previous video, where we initialized a couple of variables and then used those variables inside the loop. Those variables get updated as the loop goes on. You have to be careful with a few things. One of them is the range that you're going over. That often ends up biting you if you're not paying really close attention to how far your range is. And the other idea, which I've erased, is throwing in debugging information into your code inside of loops, inside of procedures, just to check that you have what you expect to have in those places. So just print out your variables and see what values they have.